everyone, I'm Siew, a chemical engineering student from Universiti Teknologi PETRONAS. Today, I'm going to present a project that is titled A Comprehensive Techno-Economic Analysis for Biogas Upgrading, Water Scrubbing and CO2 Methanation from Co-Anaerobic Digestion of Chicken Manure and empty food bunch in Malaysia. Malaysia is the world's second largest palm oil producer. This industry generates large amount of waste, for example, empty food bunch. Apart from the palm oil industry, the poultry industry in Malaysia is also growing rapidly due to the increasing demand of chicken meat. On average, a chicken can produce 80 to 100 grams of manure daily. The improper handling of EFB and chicken manure can lead to environmental problems, for example, eutrophication, poor air quality, and unpleasant odor. Anaerobic digestion is widely employed to treat this biowaste. The co-anaerobic digestion of empty food bunch and chicken manure helps to maintain a balanced carbon to nitrogen ratio, which improves microbial activity and increase biogas production. The main product of AD is the biogas, which mainly comprises of methane, carbon dioxide, as well as other impurities. For higher value application, for example, natural gas grid injection, the biogas need to be purified through biogas upgrading method, for example, water scrubbing, chemical absorption, pressure sway absorption, and membrane separation. Instead of flaring the captured carbon dioxide, they can be repurposed through carbon uncaptured utilization strategies to convert them into more valuable products, for example, methane or methanol. This strategy is aligned with SDG 7, 11, and 12, which promotes clean energy and optimize the use of resources. The proposed statement of this study is that currently, there is no available study that simulated the integration of co-AD of chicken manure and empty food bunch with biogas upgrading, water scrubbing, and CO2 methanation within an integrated process simulation framework. Therefore, the techno-economic analysis of such integrated system has never been assessed, which poses challenge in evaluating the overall economic feasibility. Thus, the objective of this study is to evaluate the technical performance of biogas upgrading from the core idea of chicken manure and empty food bunch by water scrubbing with CO2 methanation. The second objective is to assess the economic feasibility of the integrated system in Malaysia through a comprehensive TEA. Despite the increasing adoption of biogas plants in Malaysian palm oil mills, a significant number of facilities continue to practice CO2 flaring, resulting in greenhouse gas emission. The novelty of this study lies in the absence of Malaysian study that integrate co-AD of multiple feedstock with conventional biogas upgrading and CO2 methanation to mitigate CO2 flaring. Such integrated process simulation framework has only been reported in a single study conducted in Ireland, and a comprehensive TEA of such approach remains lacking in the Malaysian context. In terms of benefit to the intended user and society, this study helps in environmental sustainability by capturing the methane that would otherwise be released to the environment if the chicken manure and empty food bunch is left for open decomposition. Furthermore, CO2 methanation introduced also helps to reduce the CO2 emission through the process of biomethane production. The biomethane produced can be used as substitute for conventional natural gas in industry and grid application. This enhances national energy security and support Malaysia's renewable energy and decarbonization targets. This project also supports rural and community development by providing local jobs and additional income stream for farmers or cooperatives. Moving on, this project have high commercialization potential as the feedstock required, which is chicken manure and empty food bunch, is highly abundant in Malaysia. Furthermore, the market demand for biomethane is also increasing. For example, the launch of first centralized biomethane injection station in Klang, Johor in year 2025 has created a commercial pathway for biomethane to be blended into existing natural gas distribution system. The commercialization potential of the proposed system in this study is further assessed by a detailed techno-economic analysis. The process flow diagram here shows the core idea of chicken manure and empty food bunch with two integrated biogas upgrading systems used in this study. Moving on for the result and discussion, it can be observed that this integrated system produced 754.46 kg per hour of biomethane and 739.25 kg per hour of synthetic methane, resulting in 98% increment of methane yield. It can also be observed that both biogas upgrading strategies contribute equally to renewable methane production, with biomethane purity of 99.3% and synthetic methane purity of 98.5%. Based on literature for gas grid application, the methane content should exceed 96%, while CO2 should be less than 0.124%. Other gases such as hydrogen, ammonia, and hydrogen sulfide should be maintained in traces. By comparing the result obtained in this project, it can be concluded that both biomethane and synthetic methane produced can be used for natural gas grid injection. Lastly, the profitability analysis indicates that the proposed integrated system is economic viable in the Malaysian context, exhibiting a positive net present value and a payback period of 6.24 years. That's all from me. Thank you.